Thoughts of that? If I had 50 cones, how many scoops of ice cream? 50. If I had 50 sundaes, 50. And if I had total of those two together, how would I represent how many scoops of ice cream would it be? C plus S. C plus the total scoops. You can put T in there for total scoops if you want to. The T is equal to C plus S if you want to leave it to T as total scoops. That's all they're asking for in part A. T is equal to C plus S. We're taking the scoops of ice cream on the cones plus the scoops of ice cream on the sundaes and adding them together. Now, it says here, suppose you had enough yogurt for 200 scoops. Write an inequality to represent all possible combinations of sundaes and scoops. Okay, so we know this is the total scoops here. So part B now. We know that C plus S has to be what? Less than or equal to 200. Because the total number of scoops would have to be 200.
Cameron Sikora, please come to the office. Cameron Sikora.
Okay, that's part B. Graph the inequality. Is the point 20, 50 a solution? Okay, now we have to graph this. Now, I don't care which way you graph this. I might start the problem off to make my graph a little easier. I'm going to say X is C and Y is S, because we usually deal with the X and Y axis, correct? So if I was graphing this equation, there's a couple ways of graphing it. First of all, how would you graph this? So I should ask you, how would you graph this? I might go with the X and Y intercepts. If I think about this as C, this is my C axis, this is my S axis. If S was 0, what would C be? 200. So if S was 0, C is 200. And I'm going to split this up a bit. Okay, am I great? So that's a point on my graph. I'll use my X and Y intercepts. If C was 0, so C is 0, what's S? 200. And this might be the easiest way to graph this, using the X and Y intercept. Now, if I graph this, notice that when I graph this one, I'm just going to graph that part of the equation. I'm not going to go to the negatives. I'm not going to go to the positives. Or not negatives, negative of either S or C, because can I have negative scoops? No. Now, if I try a point to see what side I'm going to shade, the easy point to try is 0, 0. Correct? 0 plus 0 is less than 200. Is that true? So the part I'm going to shade that works for this equation is in there. That makes sense? Now part C is, so I shaded it in. I know which equation is going to work, where it works. Now the question comes in is 50 or 2050 or something like that? Is 2050 a solution? So in other words, if I went over 20 and up 50, right about there, is that a solution to the equation? Yeah. You know, you can have 20 scoops of one and 50 scoops of the other, still be less than 200 scoops, right? That's a solution. Now if I asked you, is 150 and 75 a solution? 150 and 75 would be right about here. Is that a solution? No. You know, so I mean, that's kind of where you look at your graph and tell me, is it a solution or not, as you go through. Does that make sense? That's part C. On the graph, find the point representing 60 cones and as many sundaes as possible. What is the S value of the point represent? So if I was doing this, 60 cones, I was right about here, let's say, and my graph is a little bit off, right there is my value of where it hits the line. What would that represent? What'd you say? 140. 140 is 140 on the line, correct? How do I know that? Because 60 plus 1 is 200, right? What would the 140 represent? Number of sundaes, because cones and sundaes have to add up to 200, correct? So that's what we're looking for here. So therefore, part D on this one is to go up and find the value here and say it's 140 and it's 140 sundaes, and that's kind of what we're looking for. So
I still don't understand parent and translating graphs. I don't get it.
Back in the previous section?
Yeah.
Okay, let's look at some of those then. Yeah, parent function, there's two types of parent. A parent function is a function that our graphs each start with, and then kind of like how we talked about where we said, okay, if it's y equals absolute value, x starts at 0, 0. And if I put x minus 1 inside the absolute value, it moves it to the right one unit, right? That's your translated function. You know, parent always goes back to the least amount of your function. Okay?
Okay. So it's like your function before you plug everything.
Yeah, before you plug everything in. So if I was looking at this, let's say for example, this equation. I don't know what kind of translations you did here, but let's say I have this one, okay? Now my parent function to this one would be y equals absolute value of x. I go back to the original equation, but as small as I can get. Because I know y equals absolute value of x is that graph, right? It's a v at 0, 0. Now what with this equation, what does that do? Up 3 and over to the right 1 unit, right? The inside the absolute value moves it left or right, and this one's going to move to the right 1 unit. The 3 on the outside is going to move it up 3 units, correct? That's what a translation is. You know, you're just looking at the translation. I don't think they did much. I think they just did translations. I don't think they did transformations, did they? That's about it, yeah. So like here, if we're looking at a couple examples, do you have anyone you want me to pick in particular or not?
No,
So if I was looking at, you did by threes on here too, or two odds?
just
Three. So let's say I was looking at number 39 here. This is on page 96. And 39 would be what?
diagonal.
It's a diagonal translation, so why is it a diagonal translation? It's moving up and over. No, another word I use, you'll hear me use it quite often. It's not in this book, it's called oblique. O-B-L-I-Q-U-E. That's the same thing as diagonal. Most of your statement tests will not use the word diagonal, they will use the word oblique. So if you see oblique, that means a diagonal translation. It's going both directions. Okay? But what it is this one's moving to the right 3 units and then down 6. Right? So let's look at 45. It says look at the translation. Let's make the translation work now. 45. So we have, it says we're working with the regular function here. Am I on the right page here? This is on page 96. 96, it says we got y equals a negative absolute value of x. So y is equal to negative absolute value of x. And what we're going to do on number 45 is, what is the translation? You know, what I always think about it is y is equal to, and I'm going to go like this.
So H is the one inside the absolute value, K is the
Yeah,
one.
H is inside, Y is on the outside. And I think they treat it as a plus. Sometimes they treat it as a plus, sometimes they treat it as a minus. How does this book treat it as? I'm going to look real quick here. It doesn't matter, it just depends on how you write the equation. So on this one, what happens here? This number 45, it moves it to the left 2 units, right? You're looking at a 45 graph, it moves it to the left 2 units, and it moves the graph what? I think it's up 2 units, right? So it moves it to the left 2 units and up 2 units. So if I move it to the left 2 units, what happens is this inside has to be an x plus 2. And moves it to the left. If it moves it, would you say up 2 units?
Yeah.
Up on 2 units, what does k have to be then? 2. So if they're answering this question with h is equal to 2 and k is equal to 2, and I don't know, let me look here real quick. Yeah, that's fine. So, I mean, that's kind of what they're looking for, coming up with the translation. The inside, you know, I think that most of this section of translation is only dealing with moving left and right, up and down. I don't think it gets into transformations. Okay? You asked me, still have about 20 minutes.
What about 42?
42 on that page, okay? Right equation needs translation, okay. First of all, if I was looking at this equation here, what do you notice? It's a V-shaped graph, right? So what we're going to do is we're going to start with this. Y is the absolute value of x plus h plus k. Now, how do I know it's not a negative? Because it opens upward. So I know it's not negative, it's opening up. Now, what in 42, what you're going to do, am I reading the right one? The way these look like, what are you talking about?
42.
You're in the wrong, it's on page 96. Now, 96 number 42, I think I'm the right one, right? Okay, listen. Now, what you're looking at is, did they move it to the left or right? They moved it to the right. How many units? 3 units. So if I move it to the right 3 units, that tells me now inside here has to be x minus 3. It moves it to the right 3 units. What else did it do?
Moves it down 2 units.
Move it down 2 units. If it's going to move it down 2 units, I'm going to have a -2, and that's going to be my equation I'm looking for. Coming up with the equation without really solving the equation down much. That's what we're looking for.
On page 102, number 48, where it has 2 absolute values.
Okay? Y is greater than that.
Would we ever have to graph them on the calculator on the test?
I'll show you right now how to do this one on the calculator real quick. I think that's it, right?
Yes. Sure.
Oh, plus 3. We can do this a couple of ways. You can do table values if you're doing it by hand. Make a table of values. I'd probably start with -3 to probably 3. Another way to do this is by calculator. I'm going to start my calculator up here. On your calculator, we're going to graph this inequality. So if you have a calculator, okay. A couple of things I'm going to graph. First of all, this is y is less than, correct? Or greater than? Greater than? So I'm just going to get my graph up here on the screen, and what I'm going to do is I'm going to hit clear, and once I hit clear, I get all the symbols. I get all the symbols I want to graph. So I want a greater than, so I'm going to change that to greater than. You'll notice right away it changes from f of x to y. And why does it do that is because f of x tells me it's a function. So I think we talked about functions before, right? Are these inequalities a function? It can, because we've got more room lines in the shape, right? So therefore, that's why it changes from function. Now, absolute value, there's a couple ways of doing this. I just type in the ABS, parentheses, and the first one was x, right? Plus ABS, parentheses, it's x plus 3. And hit enter, and I'll get my graph. Now, you gotta get the shaded area. You can see the shaded area. You can see the whole graph, and not shoot the graph by hand. Noticing now, I said, what points to pick when you start doing your table. Notice that what makes these 0? 0 and -3. Now, if I go back to my graph, what happens between 0 and a -3? It's a flat line, right? What makes those points 0 when you have 2 absolute values is where it flattens out. After that is where the slope is. Okay?
Why is it a solid line when
You can't see a dotted line on the calculator. It's very hard to see the dotted line. If I zoomed in real close, I might be able to see it, but it is a dotted line.
Okay.
It should be a dotted line. You just can't see it very well.
Can you explain more like why there are like situations when they're flat on the bottom?
When you have 2 absolute values, what happens is they balance each other. It's kind of a weird concept, but it balances each other off. One goes up, one goes down. So like if I plug in a -3 here, -3 here, and -3 here, I'm getting 0. Or get a positive 3. Okay. Now what happens if I plug in a -2 here, and a -2 here? This is going to be 2, right? And the difference between these two is always going to be 1. So 2 plus 1 is 3. What happens when you have two absolute values, it kind of has the balancing point where one goes up, one goes down kind of thing. So I always say, and we were talking about this a while back, is what makes those two 0 is where the flat line is going to be. And because if I look at my slope now on these, what's my slope of this equation? If I look, sloping going up here, and the slope goes up there. Now I think we talked piecewise functions, correct? A little bit. Now did we go into how to write this as a piecewise function? Now there's two ways of writing this as a piecewise function, and that's actually 3 different piecewise functions. Now if I was writing, don't think about this, let's just think about this. Okay. Let's pretend everything's positive. Okay. And so we don't have to worry about absolute value. If I just added this side together, what would I get?
2x plus
2x plus 6. So I'm going to go like this. If everything's positive, I'm going to get 2x plus 3. And that's going to be for x is greater than or equal to 0. Because everything's positive means this has to be positive, right? Okay, second case, let's assume it's a negative number less than 3. I think that's, yeah, negative 3, okay? Less than negative 3. So let's say negative 4, negative 5, something like that, okay? So that's my second case. So x is less than or equal to a negative 3. If this was negative and this is negative, right? Let's just think about this. Instead of absolute values, let's put negatives on it. Okay? So you got negative 2x plus 3. Everybody agree with that? Actually, not plus 3. Minus that negative has to come through. Right? Negative 2x minus 3. All right? Now, the third case is, let's say the lower one, I'm going to go right here. Let's say, which one's smaller, x or x plus 3? X. Let's say the smaller one is negative and the other one is positive, right? There's 3 cases. Okay? Now, why is there 3 cases? Now, this is coming from mathematical theory here, okay? Either both can be positive, right? Both can be negative. Or one can be positive and one can be negative, right? Now, why do I say x is negative and not the other one? Tough part to think through math. Why?
Because it could end up being positive, it's like -1.
Kind of, yep. Yeah. If x plus 3 was negative, yeah, think about it. X plus 3 was negative, what does x have to be? Think of a number line. If I think of a number, let's say x plus 3, here's a number line 0, right? Let's say x plus 3 was right here. It's a negative number. Do I agree with me? What does x have to be then? What'd you say?
A negative,
Why?
because the 3 is not negative or something.
The 3 is not negative. So if it's x plus 3, that means it's 3 units to the right of the other number, right? Think about this. If x plus 3 is 3 units right of x, right? So if x plus 3 was negative, what does x have to be? It has to be over here somewhere, right? So that has to be negative, right? So in other words, if this was negative, then this one has to be negative, and we already had that case, correct? The only case we could have left is this one's smaller, correct? If this was negative, let's say that, if this was negative and this one was positive, what happens? What happens to my x's? X's cancel out. What's left? 3. Now, here's a piecewise function. Okay, this is kind of weird, but look at the graph now. Everybody see these equations, right? 2x plus 3, 3, negative 2x minus 3. Now, if I go back, I don't know if I had my graph on this page or the previous page.
On the calculator.
Oh, it's on my calculator? There we go. 2x plus 3, does that look like that line? Correct? Up 2 over 1 crosses that 3, correct? From 0 here is a horizontal line of 3, correct? And from here to here is a slope of a negative 2, and a y-intercept of, what did we say? -3 or something like that, correct? So those are the three equations of this graph. Absolute value is based on piecewise. It's a very abstract thought. That's how you come up with the piecewise. So that's kind of where I say, don't worry about getting caught up on that gap. You will get to. That's kind of where piecewise comes from.
So why, if in the original equation, the +3 was in the absolute values that you moved up to?
Why is it moved up 3 units? It's kind of putting two transformations together. What it kind of does is it takes, let's think about this way. You're taking the absolute value graph on x. Here's my absolute value of x, right? And I'm going to put it now x plus 3. Oh, wrong way. Okay? And this one goes. Is that about right? Do I agree with me? Now, when we add these two together, let's pick an x coordinate, and say, okay, what's happening? And we say, okay, my scale might be off a little bit here, and say, this plus this is what? What we're doing, we're adding these two graphs together, and working on the x coordinates. Saying, okay, if the x is 0, what's the two x's added together? Okay, I don't know if I have my right values in here right now, but that's kind of what we're doing. We're adding together the two values. We're going to get more into that later, but we'll get caught up in that too much. With absolute value too, I just want to explain where everything comes from a reason. That's kind of why I showed you the piecewise a little bit too, not to get you caught up and say, oh, I'm totally lost, but I want you to understand that piecewise and absolute value will hand in hand together. We will elaborate on that later on when we start doing more equations. But right now, I just want you to, probably the easiest way to do these values is to make a table. Knowing that, what makes these 0? So if I was making a table of this equation, let's say, for example, if I was making a table of this equation, where would my table go from? Where would my flat part go from? -1 to 3 is my flat part of my graph, right? -1, 3. What makes the first one 0? -1. What makes the second one 0? 3. That's where my flat part's going to be, right? So can I just graph from there? No. Now I need to graph looking further up to get the graph going up, correct? So I make my table from -4 to 6 or something like that to get our values that I need for my graph. That makes sense.
So if you did do that, you plug -4 into both of them.
Yep. Yep.
And then you get 2 to
Yeah, if I plug in -4 for both of them, I would get -4 plus 1 is? Absolute value is 3. -4 plus minus 3 is?
-7.
Absolute value is? 7. So 3 plus 7 is? 10. So that's my value there. Okay. If I plugged in, let's say I plugged in 0. 0 plus 1 is? 1. 0 minus 3 is? -3 absolute value is? 3 plus 1 is? 4. So my value there would be 4. I'm guessing it's going to level off at 4. If I keep going, if I try a -1, that'd be 4 too. I don't usually get too hard of those questions on the test. Mainly, we're going to talk about these more later on, but I want you to understand that for the basics, how to make a table like this.
Is this when you graph the parent function?
There's different ones you can do. I didn't graph the parent function in this one. What else?
You do an easier one like number 5 or 81. You haven't done that in a while.
An empty 5-gallon water jug weighs 0.75 pounds. 3 cups of water inside a jug weighs 2.25 pounds. Predict the weight of the jug with 5 cups of water inside. Okay. A couple things you could say. What variable? There's 2 ways of writing this. it depends on what variable you let be x. You know, like here I could say x is my weight, and y is the amount of liquid. And I didn't spell that right. Or you could go the other way. X is liquid, y is weight. You know, it doesn't matter. Your equations will be a little different. You should get the same answer as you go through. Now, if I was going on here, it says to start with number 5, an empty 5-gallon water jug weighs 0.75 pounds. So we know the weight and liquid. Now, let me think here. How will I do this? An empty 5-gallon water jug weighs 0.75 pounds. So I know that 0.75 is my x. How much liquid is in there is 0. Right? If I'm setting up the variable this way. Some of you probably set it up the opposite. The second equation says, with 3 cups of water inside, the jug weighs 2.25 pounds. 2.25 with 3 cups of water. Now, if I want to solve this equation now, first of all, I need to find my slope. So I'm going to find my slope on this equation. Now, there's a couple ways of doing it. Not a big deal here. Change of y over change of x. So I got 3 minus 0 over 2.25 minus 0.75. So 3 minus 0 is 3 over 1.5, I believe, which is 2. That's all right? Like I said, you're going to get a different equation if you set your variables the other way. Now, if my slope is 2, I'm going to go into this equation and go y minus y1 so I got y. I'm going to use this second point here, my first point. Y minus 0, slope is 2. Correct? I use my first point there. I don't care which point you use. You can use either point. It doesn't matter. If I work this out, knowing what my variables are, (2x minus 1.5). Now, if I look at my equation, now it says predict the weight of the jug when 5 cups of water is inside. So which one's 5? Y. So I'm going to put 5 in for y. I'm going to add 1.5 to both sides. I'm going to get 6.5 is equal to 2x. Divide by 2. 3.25. So the amount of liquid or amount of weight, 3.25 pounds. So it depends. Like I said, it's not a set way. And I think a lot of you, when you did this equation, you went the other direction, and you set up x being the liquid and y being the weight. That's fine. You're going to get a totally different equation. The equation is y equals 0.5x plus 0.75 or minus 0.75 or something like that. You know, so it's opposite. Did you get a different answer at the end?
No.
No, you're still going to get the 3.25 answer. It depends on how you set up the equation. So, any other questions? I think we're running out of time. What we'll do is I'm just going to stall it off for a couple of days here. We will have a test on Friday. I'll send one more tomorrow, answer questions. I hope you have questions for tomorrow. Right? It's on there. So. Yeah, it's been on there since last week, I think. So. Is it helping today a little bit? I know Mike being gone, I was going to cancel my meeting yesterday. So I will be around if you have questions. Get them to answer questions. I'll be get through this chapter as soon as we can here. Absolute value shouldn't be too bad. The inequality stuff we dealt with before, a little bit of shading. So and make sure you get them answered. The quizzes that we did the other day work better. Still not the greatest. I'm going through it. I know a couple of things I can point out right now is we have a hard time with fractions. Hard time with fractions. Subtracting negative numbers. There's 2 things we need to work on: is negative numbers and fractions. It's surprising what we had in this quiz. But I think I have your class correct, and I don't think I have the other class correct. So I have this class, and if I did not get a quiz, I don't even know where it is. I went through and corrected them all, so.
I wasn't your checker, how about 7,000?
I'm not gonna be able to take it. And this will be your test, and what I'll probably do tomorrow is, if there's not a lot of questions, I might have you do some stuff with, like a review test or review in a book or something like that, have you practice problems. This will be a big thing, like I said, parent-teacher conference is on Monday, I want decent grades, and you will, like I said, I'm hoping next hour you will have everything updated so you know where you're sitting.